Okay. Okay, guys, I hope you can hear me. We had finished this. I'm saying I'm not writing this again. I have already demonstrated. So if you just look at the X note here, I've already told you that this one is going to take the generic form. And what is the generic form? The generic form is basically this one here. If you look at this generic form here, it's going to take this generic form. You can see we have our XT here. So XT takes on this form. Where? XT takes on this generic form. Why does it take on this generic form? It's because the question given in terms of FT, it runs from -1. This is less T, less 1. This is what you have. And this is a Fourier series, full range, which is this one in red. So since it is this one in red, remember I have X prime prime, then you are going to differentiate this equation 3.9.4 twice. And if you take the first derivative, of course, this one is a constant, it will go. You'll get this one here, it is n pi negative. The first derivative, maybe I can use this here. The first derivative here, now we are looking at x prime. The first derivative of this one will be, of course, we have a sum. This will be a minus. This is n pi. This is what I was trying to say. Minus n pi. This is n, then a cos. Okay, and this will be plus first derivative. This is a cos. This is n pi. Sine becomes a cos over that angle. Then second derivative, which is prime prime, we differentiate the cos n pi here. This is a sine. This is sine. This is sine here. When you differentiate this sine, it is going to give you a cos. So this one will remain as minus. The n pi comes here, which will be minus n squared pi squared, and this is cos. Since the first derivative gave us a sine, then here it will be minus. This cos will give us now a minus n squared pi squared. Remember, it is second derivative. This is pi squared sine of that angle there. That is what you have. I hope I'm clear there. So since that is the case, once you substitute those in, then we can go back and we express them. This x, we have got the x prime, we have got the x prime prime. Now simply come down here and substitute them back into this equation here. What we've got is what we are going to substitute into that there. And then we equate it to the Fourier series representation of this function ft, which is equation 3.9.2. Okay? If you do that, you get this term here. That substitution is going to give you this entire thing here. Okay? And what happens here is simplification. So once you have this, just simplify this guy here. Once you simplify this guy, the question is, what do you get? A simplification of that, just take out the sine and the cos. If you take out the sine and the cos, remember we are saying this one here is this whole thing is ft, which ft is this. But here, what brings this to an end, the question here is the odd and the even. Remember, we said for n1, n equal to 1, and n odd, you'll get this one. Is that okay? Then, so long as the n is even, it will be 0. That's what simplifies this. So just throw in n0, n. This sum can be simplified with respect to the nature of the n. Remember, this is cos n. Cos will always be even. And once cos is always even, we are saying this one will give us a 0, implying that the whole series disappears. But once n is odd, so for n even, you have 0, you have 0. Any odd, you'll always remain with the sign. These ones we have already done. So to simplify that, you just have to play with the n, the nature of n. Is it an even number or an odd number? And remember, you cannot exhaust n. N goes up to infinity. That's why this sum here can be simplified to this by simply taking on odd numbers, because all of the even numbers to this are going to give us those zeros. So we don't need the even numbers. For the odd numbers, we will get this term here. I hope I am clear there. Hopefully I am clear. Okay, and from that, you conclude. How do you conclude from this? From this, I hope I'm not having too much noise in my background. I'm in office, and I think my colleagues are excited about a PhD defense. So those voices that you may overhear, I think are indicators of a jubilation. But your time is also coming. Soon you'll be jubilating, and I dedicate to you songs of jubilation. So pardon me on the saturation in the background. Apologies. I hope it will die out soon as members descend from the gathering. Okay. So this is what I was saying, that for BN, remember this is a sign. So if this is a sign, then it would imply that the generic term of the coefficient, this 2 over n pi is a Bn. And because it is a Bn, when you deal, remember, okay. I'm talking about this term here. You have that term. So you have a sign, and remember you have also a cos here. So you are looking at this term. You also have this term here. These are driven by the nature, and we have noticed that for any even, everything disappears. We remain with any odd. Any odd will give us only the second term. And now for the second term here, that is where, because if you remove the whole of this, you're going to remain with only this term here. And in this term, for the, maybe I now have to encircle, since this whole thing is out. Just give me a second, guys. Jim, look at me. Oh, okay, that's good. Okay, yes, guys, we are in the last part of our lecture, which is ending in the next few minutes at 2 sharp. Yes, so I was saying that given the values of n, this one would all disappear. So we remain with this term here. Maybe by that term remaining, I need to remove the red now here so that the term we are talking about is clear. So we remain with the sum of this term in blue. I hope I am clear there. So when you remain with this term in blue, so the question is then, how do we go about this? Now here we have to make our n, rather bn. Our bn must become the subject of the formula. But remember, what we have this way is now going to be equated to this one here. So what we are doing here is we are equating this to that. I hope I'm clear here. Hopefully I'm clear. What I have in blue, remember this is the equation. The equation, which is the right-hand side. What I have in blue here is not the right-hand side, but rather the left-hand side. What I have in blue is the left-hand side, which is this equation. Is that okay? This is the one in blue. When I simplify, I remain with that. But remember, the right-hand side of this equation is this ft. But this ft was determined as this value here. So the left-hand side is this, and then I'll use color green. This one here, the green is so thick, you may not even know that it is green. Some of you who are colorblind may think that it is black. So let me change maybe to a lighter green. So this one here, I hope we are together. This is now the right-hand side. Remember, we had x prime prime plus 2x, which was equal to ft, and ft was given as a full range Fourier series function. So we have our left-hand side, which is equal to the left-hand side equal to the right hand. And if you equate this to that, of course, we'll ignore the sum. The sum for both of these is n odd, n odd. So we will make bn the subject. So if you look at the left-hand side, I'm going to make my bn, but now this is sine n pi t. So if you take out the sine n pi t, guys, you need to be attentive here. I cross out this and I cross out that. I'm comparing the coefficients of sine n pi t, sine n pi t. So I remain with this term, which is 2 minus n pi, the whole thing squared bn. I'm interested in the bn alone. Okay. What do I have this way? This way, I simply have a 2 over n pi. Okay. This one, I am dividing it by this term here. So if I call the whole of this term in black, the term in black, if I call it alpha, so I am dividing this by alpha. Okay? Dividing by alpha here would definitely imply multiplying by its reciprocal. Now I don't want people to get confused. And if that is the implication, it would mean that now I have this one, instead of divided by alpha, now it becomes times 1 over alpha. But remember, the alpha is the 2 minus n pi, the whole thing squared, which is this term here. So I end up with, so instead of alpha, I can now substitute, instead of this alpha, I can substitute my 2 minus n pi. This is a 2, this is minus n pi. This one is squared here. Is that okay? Then you have this thing here. So when you square both of these, that's why you see here it is 2 minus n squared pi squared. The 2 you see in the numerator here, it is that 2. So it means our Bn becomes the whole of this term here. And since we have this as Bn, we can now go back and we deduce, because remember the generic form of the solution to this non-homogeneous differential equation using the Fourier series technique in solving it would imply that now our x prime prime plus 2x is this whole statement, but we replace Bn with this term. So it implies that now the Bn that we have, let me use maybe this color here. So this Bn we have here, I hope you can see this color here. It's going to be replaced by what I have circled here, or rather enclosed in black. It is going to be the whole of this one here. I hope I'm clear. And once you substitute this Bn with that one, then you'll have got the generic solution to our system. And remember, it is a half. Remember, these ones have already disappeared. You got it as your x naught, which was a half, the xt, the generic form of x. Remember, this is x prime prime plus 2x. But the representation of x, in the representation of x, we are going to substitute the Bn with this. And that representation of x, if you allow me, we go to the representation of x. Oh, okay. We can scroll. Okay, it is right here. You can see this statement, equation 3.94. Equation 3.94. If you substitute into 3.94, it gives that answer. Okay. Before I go into the chat to see the questions which are there, okay, so what we have now, when you substitute it back, our Bn, you can see that when you bring the Bn and you substitute it back into our 3.14, where is our 3. Not 3.14, but rather, that was what? That is 3.94. If you come and you substitute and you simplify, you end up with this term here. That is the a quarter summation n into n over that sine n pi. And if you wanted to know how you get the a quarter, remember the n naught is 1 over 2. So if you substitute this n naught, which is 1 over 2, into equation, generally we are substituting the whole of this. We are substituting the whole of this into equation 3.92. If you substitute the whole of this, the n naught is a half, n naught over 2, that will give you the a quarter, the n is 0. That entire Fourier coefficient with its cos n pi t disappears, And then you remain with the Bn. Bn is 0 for any even, and it is this term for any odd. So you are looking at this simplification. The simplification is specific to n being an odd value. Okay? And with that, you end up with this statement here. So this is our final answer. This is the final answer here, guys. Okay. Now I can go through the chart and see what is in the chart. Sentongo says, maybe I will start from up here. Why are you missing out the Fourier coefficients while differentiating? No, I'm not missing out the Fourier coefficients. I don't think I missed out that. This is Gonza George. You probably misunderstood my differentiation. Gonza, you are saying, why am I missing out the Fourier coefficients? I differentiated with them there. Otherwise, in the final simplification, you wouldn't get Bn and An and N naught. If I was leaving them out, you probably misunderstood the differentiation I was performing. There is no way we would have had the coefficients in the final expression. Yes, this is who, Nuareva. Okay, Nuareva's question is quite long. You're saying, but now you are confused with this example. How do we choose yt or xt? I thought you look at the nature of the function. I don't understand when you say choosing yt or xt. You're saying you thought we look at the nature of the function that makes the non-homogeneous and guess either. We are not guessing here, Mr. Nuareva. You are saying you guess either for full range or half range with the function being even or odd. I think I just needed to clarify to Nuareva in a summary. I'll just try to pick highlights and I summarize that example to address the confusion Mr. Nuareva is having. Zakaria says he's okay. The sign is 0 for all, whatever even or odd. Yeah, whatever even or odd, this is who? This is no 0 for all n, whether I've not got you, Mr. Sepuya. Some error in computation of n naught. It's a quarter. This is Sentongo Albert. Okay, I think I have picked the highlights, what people are saying, but most of the comments have not come out explicitly clear, but I have managed to, I think, understand them in a jumbled format. Though I have understood them in a jumbled format, I'll try to answer them explicitly so that you get it clearly. Now, one, I will not recall the names, but one of you asked why we are differentiating while leaving out the Fourier coefficients. We've not left out the Fourier coefficients, guys. This is our example. I have told in the previous example, we said once you have this, you have ft. This function is a piecewise function, and it is defined as this. Between -1 and 0, it is 0. And then in this range of 0 to 1, it is 1. And given this, we already have this, we can compute the Fourier coefficients because this is a Fourier, rather full range. So we can get the Fourier series expansion of this function. Is that okay? And we are saying from that, if you use this, we can get the Fourier coefficients. Getting the Fourier coefficients, we got C naught to be that, we got Cn to be that, we got Dn to be this one here. And with this said, we substituted. Substituting those back, they gave us our Ft. I hope I am clear here. So this is the representation of Ft. I guess I'm clear here. So since we have this as the representation of Ft, but remember, Ft is the non-homogeneous, remember the other one is a non-homogeneous differential equation. So that function Ft is this. So it means now we have to bring our x, this x prime prime plus 2x, and we equate it to this term here. So instead of instead of this f here, if I erase it out like that, I can now say in here that instead of this, I now have, what do I have? I have x prime prime plus 2x, which is equal to that term. Because remember, this was our Ft. Is that okay? And it is clear. Remember, this is 3.9.5. Now we are saying substitute the solution xt, that is equation 3.9.4 into the ordinary differential equation 3.9.1. When you substitute into 3.9.1, it gives this. That is for the left-hand side. Remember, we have this. The N naught was 1. Remember, the other one is C naught over 2, which is their half here. Then plus the Cn, the Fourier coefficient Cn was 0. That's why the cos has disappeared here. And we had the Dn. The Dn is the 2 over n pi for n even, rather for n odd and 0 for n even, which is this term here. And here we are saying, after getting this, this term here, now we have got x prime prime plus 2x. Is that okay? Which gave this form here, this form here. But now we are going to equate the whole of this. We are going to equate the whole of this one, which is the left-hand side. We will equate it to this one, which is the right-hand side. Please, what I'm calling the right-hand side here is this equation 3.9.5. But remember, we said the generic form of this equation here, this non-homogeneous equation, x prime prime plus 2x, which is Ft, it has already been represented up here. That is this one here. We have it as xt, n naught over 2, then this is sum. Why this? This is simply because what we have there is a full range. And because it is a full range, you have n pi x over L. But remember the L, you see the denominator here, there is nothing. Since we are moving from -1 to 1, so our L is 1. 3.9.4, this represents the general form of the solution of xt. So once we get those coefficients, rather we have this, we compute using the xt, we compute n naught, we get an and we get bn. And that one we have got that as this one here. If you keep differentiating and you substitute, we ended up with this term here. So this equal to that, it gave us our n naught, because when you compare now, You just do a comparison. Do a comparison of the left-hand side and do it with a comparison of the right-hand side, guys. This is the right-hand side. If you do the comparison, it comes out directly. This N naught here before the sum, the N naught goes with a half. That's why we deduce here that therefore N naught is a half. Why? You have the N naught, it is here. If you compare the left-hand side with the right-hand side, the N naught, which is the N naught on the left-hand side, is equivalent to this half on the right-hand side. So N naught goes with this one here. Now, this side here in the right-hand side, there is nothing to do with the cos. You can see we have cos n pi t. But remember when we computed the coefficient of Cn was 0 and the entire cos with its Fourier coefficients disappeared. That's why when it comes to this term, if you allow me to highlight it in yellow, the color of these movementists, this one here, because there is no cos in the right-hand side, this is equal to 0. This one is equal to 0 because the right-hand side does not have any cos. Then we remain with the sign. So what about the sign? Here we have sine and we have sine, and that's why I said that in that case, given that there is a sine and sine, the angle is the same. We have this bn over that. We have 2 minus n pi. This whole thing is squared. Is that okay? And the whole thing is bn. We are saying that this one will be equal to 2 over n pi. 2 over n pi. Make a bn the subject, it gives you that term we saw down there, which was 2 over n pi into 2 minus n squared pi squared. And that is this term here. I hope we are clear there. Okay. I see there still is ft. This is a 2 Jimmy. Difference between ft and ft. Now I don't know what Sergo is saying. But anyway, I think I have preempted your concerns. I think I have preempted all of them. We can look at other related examples. There is this one here. For those, we have an example. This is to do with the resonance. Find the steady periodic solution to the equation, that one. Is that okay? So you have x 2x prime prime 18 pi squared x is equal to ft. Same story here. Since it is the same story, we have ft, which is given by this. And the guy who was saying, there is a guy I think I have not answered who said it is confusing. Maybe I need to answer this one specifically. There is a guy, I'm trying to look for that chat. Yes, I think this is Noareva. Noareva says he's confused YTXT. He thought that, okay, I think Noareva, Albert, I guess you're still online. And I'm now talking to you. I'm trying to do away with your confusion. Noareva, if you are there, you can say a yes in the chat and I'll be happy. If you are there and you say a yes and good. Now, your confusion, I think if I try to understand your inquiry, is based on this. So we have xt. This is the generic solution, the generic form of the solution of xt. Why? This is based on the nature of the solution that is going to be derived for ft. ft, you can see it is, this is a Fourier series expansion. We can get a Fourier series expansion of this piecewise function, f big. Why? This one runs from, it is -1 between -1 and 0, and it is 1 between 0 and t. So since we have this, we have already derived the formulas, the integral equations or formulas for establishing or determining those Fourier coefficients. So you can find A0, AN, and Bn of this Fourier, rather this piecewise function here. And I have already told you that if you have this equation, let's say you had been requested to verify that this x, a certain value of x is indeed the solution of this non-homogeneous equation. It means you're going to get a certain value of x, substitute in this, and you verify that the left-hand side is equal to the right-hand side. So the question is, ft, the nature of ft should be mimicked in this x here. And I started by reviewing part of our differential equations 1. I told you when you discussed those principles of superposition and you looked at solving non-homogeneous equations, you would look at that function that would make that fx not 0, that would make that equation homogeneous. And I said if it was a linear function, something like maybe 3x, then your yp would take the generic form of a linear function. And in this case, I use the alpha x plus beta. Is that okay? If it is squared, then you would have a generic representation of the would-be yp solution of that non-homogeneous system as ax squared plus bx plus c. Then that's what you would differentiate. The same applies here. I have this which is periodic. I have a function which is ft. Ft is piecewise from -1 to 1, and I can get the Fourier series representation of ft, which is this. This indicates that the solution I'm getting x will also take that form, because remember, for me to get a certain value of x and throw it here and use it to verify that x is indeed a solution to this system here, it must somehow have, I could probably use the word properties similar to what we have in ft. And it is that very concept that was used in solving non-homogeneous differential equations. So with respect to that, we get our x, and I am saying x will take this form. Why this form? This is a Fourier series expansion, full range according to this piecewise function. And this